I'm going to take you through the AP Calc AB 2014 number 1. So this is the grass clippings question. It tells you from 0, including 0 to 30, the grass clippings, the amount of grass clippings. Now, setting aside that this is got a lot of decimals in it, you know, since this is question number 1, this will be a calculator question. So you'd be using your calculator for this. It says A of t is measured in pounds and t in days. All right. Find the average rate of change, A of t, over the interval. Indicate units of measure. Anytime they want the average rate of change, in your head you should think slope. So, average rate of change, right, and that's the secant line. The average rate of change is the secant line. So we want because this is y2 minus y1 over x2 minus x1. It's the slope of the secant line. So this ends up being, I don't know, you plug 30 into here, subtract it when you plug 0 in for here, and divide that, you end up getting negative 0.197. Now, they want units. Well, rate of change, right, always means 2 units. So I know the top, look at the top and the bottom. The top is in pounds, so this top will be in pounds. The bottom is in days, so it's going to be pounds per day. Okay, part B says, find the value of A prime of 15. Using correct units, interpret the meaning of the value in the context of the problem. Now, this A prime of t, do on your calculator. Just go ahead, put it into your calculator, and you end up getting negative 0.164. So it says, what is the meaning of this? So let's think about this for a second. You know that the function they give you, A of t, is the amount of pounds in the amount of grass clippings in the bin. So the rate of change would be how fast those grass clippings are decreasing, because it says they're decomposing. So if you're talking about a rate of change, especially if it's negative, then you really know it's decomposing. So this would be the rate at which the grass clippings are decreasing at 15 days is negative 0.164. I should say, instead of rate, why don't we use the word amount? The rate at which the grass clippings is decreasing is good too. That's not wrong. But I feel like, and you'll see this in the scoring guidelines, they use the word amount. And that indicates that you understand that the actual amount of grass clippings is changing. It's getting smaller, right, because they're decomposing. Let's look at part C. So it says, find the time t for which the amount of grass clippings is equal to the average amount of grass clippings. Now, anytime you see the word average amount amount is always that thing you do, that thing you do where you take 1 over b minus a of the integral from a to b of f of x dx. Remember, that's average amount. That tells you the average. And if you think about it, it makes sense because the integral will tell you area under the curve, which is total amount, right? You probably talked about this in your class way back when you first started integration. And when you put it over b minus a, well, that gives you an average. So, that gives you the amount over time. Okay, so, but we want the time where this guy, so what are a and b? A is 0, b is 30, right? We're going from 0 to 30. So it'd be 1 over 30 of a of t dt. We want to know when is that equal to the actual amount of grass clippings that are in the bin. So we need to find a time when the actual function a of t equals this. So I set this equal to the actual function, right? Just to write it out so you can see what it looks like, that means this. Oh, this should be a 30 of okay. So now I have to solve this. So what you end up doing now, if you're having trouble following the algebra, you will have to take the log of of both sides at some point, and then take everything to an e or whatever. You could multiply. You could start by multiplying both sides by 30 if you want, and getting rid of the 30. You might see that you can actually pull this out since it's a constant. And that these will end up canceling. So what I would do at this point is put this into your calculator. Put it in your calculator. So make sure you go to math, you go to FNINT, and you just fill it in. Don't forget to divide by 30 once you find it, because a lot of students forget to do that. And also make sure you are in function mode. If you've been doing anything else in your physics class or whatever, sometimes your calculator ends up in a different mode. Okay, so when you do this, you get on this side 0.411639, blah 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 blah. Don't use that rounded number. Remember, if you want, you can store it. And I have another video for how to store things, but you can store it as a, if you'd like. What you end up doing is taking the log of both sides to get this t down, right? Because then it becomes, right? And then I divide both sides. Okay, so when I do that, t ends up being 12.414. And don't forget your units. Okay, last part. This is the question where they want a linear approximation. Now, everyone has probably seen linear approximations. You may or may not remember the linear approximation formula depending on how much time you spent on it in your class or whether you reviewed it or this and that. If you want to skip this part of the question and come back to it, do that. Great. Go and do the rest of the test. Come back to this. If you want to start it now, then start it now. So, linearization always has the same formula. F of the value plus f prime of the value times x minus x naught. Now, I use x naught, x sub 0. Your teacher might have used something else. But that just means at a specific point, right? Now, what you do have to calculate is, since we don't really know how to take the derivative of this very easily, you should just do it on your calculator. Or you might know how to do it, or you might not know how to do it by hand, but don't waste your time doing it by hand, do it on your calculator. And the AP test is going to expect that you did it on your calculator. So you might want to say, okay, so I need to know, so for us, this would be now, why is it 30? It's telling me for t is greater than 30, the linear approximation to A at t equals 30 is a better model for the amount of grass clippings remaining in the bin. Use L of t to predict the time at which there will be 0.5 pounds of grass clippings. So the first part of that question for t is greater than 30. That means that 30 will be our first point, right? Because they're saying for it being greater than 30, when it's at 30, that's a good approximation. So I'm going to use what it is at 30 to approximate, which means that my x sub 0, my x naught, my first point is when it's 30. So that's why I plug in 30. Here you're going to do a prime of 30 times t minus 30. What are we doing? We're actually setting this equal. We want to know when this we're solving for t. Okay, so I am going to set this equal to 0.5. This first guy ends up being 0.782928, blah 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 blah. And so I'm gonna keep that in my calculator. I'm gonna store it as A. Okay, and then I'm gonna do the derivative, which ends up being something like negative 0.055976, blah, 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 times t minus 30. Okay, and now I'm going to isolate the variable because I'm solving for t. So first I'm going to add this. Okay, then I'm going to divide by and then add 30. Something went wrong here. Well, here's a good example. Something happened and I got 7. That's not right. I can't get 7 because t has to be bigger than 30. So clearly I did something wrong. So I'm going to go back and look at what I did. So I had 0.5. I'm just going to do 6.687 times 0.931 to the 30 just to double check. So 0.5 plus, look at what I did here. I added this instead of subtracting. That's not good. So this should be subtracting. Okay, so 0.5 minus that. And then good. I got 35.054. And that would be it. So I made a mistake here. I make mistakes too. This was good though because I got to see, well, that mistake didn't make sense. You know, when I got to the end of that answer, 7 isn't going to make sense. It has to be something bigger than 30. So I went back. I see what I did. I looked at what I did, and I found my mistake, and then I got it. So that is 2014 number 1.